Hi guys, Robin here. I wanted to look at the NEA and basically how do you get an A star in that NEA? The NEA takes 20% of your final grade, which I know doesn't sound a lot, but actually can make a massive difference to your potential grade. What it also does is it gives you confidence as you go into the exams at the end. You already know you've got a good solid set of marks behind you already, and therefore you can kind of go in and really sort of get a good idea of what potential grades you're going to be getting at the end by how you've done in assessments and that kind of thing. So it can be really quite powerful. What I would also say though is you can't get an A star without having done marks within your NEA. It's impossible. That even if you've got 100% in both exams, you still can get an A star. So our NEA plays a crucial role in gaining that A star and making sure that it becomes a possible task for us all really to achieve. Our first thing to look at then is the actual business that you're going to do this for. And I say do it for a business. When I mean that, it could also include an organisation, but if you want to do your system for somebody, for fixing some form of problem, this is crucial because it gives you things to talk about, it gives you things to focus on. So, for example, we want to be able to look at the business, and we want to look and think about, well, what is our system going to require? What features are they going to need? What kind of aspects is it going to need? How is it going to suit them in the very best way? So when we're looking at our chosen business, we want to basically introduce them. Who are they? What do they do? Where do they do it? What kind of aspects do they cover? What kind of functions does their business carry out? And the more we can think about this and understand them, the better we are inevitably going to make a system for them. So in other words, we're looking at their successes, we're looking at kind of what improvements can be made to their successes, but also looking at what problems they face. And ultimately, we want to fix at least one of their problems. When we're trying to understand them, we want to think about the stakeholders that are involved within that business. You can see I've listed a few here as examples. When we're thinking about these people, we want to think about what impact are they having on that system? Do they use the system? Are they influenced by the system? Do they not use the system ultimately? But do they require data, or do they require some form of function of that business for them to be successful? So, for example, something like the manager may never use the system themselves, but they obviously want it to be a success because that's going to impact on sort of their prospects, their career stability, all of those sort of features. So when we're thinking about these stakeholders, we can take this further. What does the interface need to look like? What does the language that they need to use? Do they need specific language? Is it language that will kind of aid their understanding? So if it's a customer, they want the language to be simplified so that they understand what's going on, whereas a manager may have like jargon or slang that they may use within the company that therefore they understand and therefore they will use. Will your stakeholders need training? Will they need security permissions? What's required within your system? What we want to then do is think about our computational approach. How are we going to approach this system and actually think about why it's making it better for the user, for the company, sorry. So in other words, we want to think, well, why are we actually bothering? Why don't we just do this on a pen and paper? What is it about a computer that is going to help to fix their problem? Is it the ability to search through large sets of data? Is it the ability to sort data? Is it the ability to communicate? Is it the ability to sort of share information across a really like the global sort of network? Is it what's needed in that situation that makes your system the best solution for them? In doing so, we need to think ahead. We need to think about what inputs are going to be required and what outputs are going to be required. And again, if we think about those two things, we therefore know what data is coming into the system and we know what data is going to need to go out of the system and what processes those need to take. We should think logically about these steps. So what kind of happens within the system, what happens that's activated by the user, selecting options or clicking on buttons or those kind of features, and what happens by the system. So it might be that the system has automated functions. It uses timings. what's actually going on within the system to create decisions, to create moments and events that will take place. What we want to do is try and take down this scary proposition of this entire system and break it down into smaller chunks. How can we break it down into smaller aspects so we can approach and deal with each of those aspects better as we move forwards? Once we've done that, we can start to think about the processes that we're going to take place. We're going to think about the steps that are in place, and therefore kind of how will they kind of be worked through? How will they be solved? Do certain things have to happen in a certain order? If that order's broken, what kind of issues does that create? We also then need to think abstractly about our system. So what things can we get rid of? What data just is not required? What content within images within the user interface is just not required? And therefore, if we can get rid of that, that's going to help out the user. It's going to help out us to organise it. We've simplified the whole process down for ourselves into a manageable format. What we want to then do is think about, well, what things can go on at the same time? What features of the system have to happen one before the other? How's that going to improve sort of the performance of the system? How is it going to improve the experience for the user? Is it that something can be happening in the background that the user isn't necessarily aware of, but is ready for when the user needs it, because it perhaps takes a long time to process that particular aspect, that particular component of the system? What we then need to do is think about our stakeholders in more detail. So we want to think about them as individuals now. Again, going back to their needs, what specific language do they need? What is language that's going to suit the customer that isn't going to be used for the manager? What levels of training are going to be required? We can't give the customer training necessarily on our system. It therefore needs to be designed in a way that they can just use. If the system is going to be used within the business, and therefore is going to be used by staff, well then maybe we will use training to help them use it, to help them understand what's going on, because it's a more complex sort of system for them to use in that regard. We also then need to think about what documents are being used, what sort of features are being used within the system. We also want to discuss and talk to our stakeholders, talk to our users, interview them, question them, find out about that system. So it's a process we need to go through and show that we've done that. We also need to carry out some research. What other systems are out there that are similar to ours? What ideas can we steal from them ultimately? What kind of ideas can we borrow from them in the way that they've approached a solution that we can perhaps improve, enhance in some way? So first of all, when we think about our user interviews, we want to think about, well, who are they? So we want to find out these things, don't we? What do they require from the system? What problems do they face? What solutions do they have that they think might solve the problem? What things are going to limit the potential solutions? How's that? What kind of are their must-haves that they just definitely require, and you can't kind of ignore? You can't sort of skip. And if they don't have those things, does that ultimately mean the system is going to prove to be a failure? In doing so, we should therefore be really clear about what our essential features are. What kind of aspects are going to ensure success or failure of the system. We also want to think about any potential customization as well. What kind of things can the user change, edit, alter as they move forwards? So we think about our essential features, we can break these things up. What are things that are absolute must-haves? What are things that are just desirable? And what are things that are pretty much just an absolute no, they should just not be in the system? That might be processes, it might be data that's shown to the actual customer that might be secure for the business and you don't want to share that. It might be processes and steps that must happen, such as validating a user when they sign up, that kind of thing. So some of those might be desirable and some of them might just be absolutely essential. What we also need to think about, though, is our limitations as well. So what things are going to hold back the success of our system? When you think about it, you're an A-level student, you don't have a budget, you don't have limited hardware you can use, you possibly don't have a range of input devices such as barcode readers, as like a VR headset. you might not have access to those things, and therefore you can't include them in your system. So you've got to bear in mind what things you do have and what things you don't have access to. So when we think about these limitations, it's worth thinking about certainly the budget, certainly the time that you have. You have a limited time during your course to actually work on this system. And again, your own technical expertise, your own coding ability is going to impact on the potential success of the system. So you need to bear that in mind and factor that into what you want to achieve. We should also really think about the legal aspects as well. And I would really, really encourage you to include at least one law that is going to impact on your system. Is it data protection? Is it something like the Equality and Diversity Act that therefore is going to mean that you need to include features to make sure that that all users are included within your system? What are you going to put in place to ensure that those things happen and those laws have been met? Once we know these user requirements, we need to then talk about them. We also need to think about the hardware and software. So when we think about these user requirements, you can see here I've included some. Which users require a password, which don't. Which users are going to use the system, which don't. And again, we can sort of think about these requirements in quite detail then, and the more we understand them, the better it's going to be for the user. And again, you can see here I've gone even into more detail about the individuals, and you can see, for example, that we've got Eugene, who's an administrator, so in other words, a member of staff, therefore comes under the Equality and Diversity Act. We've got to make sure this system works for him. But because Eugene has dyslexia, it requires the background of your system to have a yellow background so he can read it properly. In other words, that becomes an essential item that must happen within the system. Whereas the customer, Danny, doesn't need those requirements, but needs a simplified system that he can use without any retraining, but also doesn't require any jargon or any technical language, so they can use it and so they can access the system very simply. So we've now got to be able to cater for both different types of user. When we're thinking about the hardware and software, we want to think about kind of what is it that's going to be required to make this system run. You're doing a computer science course. You should therefore be specific about this. What RAM is required, what processor is required, what hardware, as in like the hard drive is required, any other sort of outputs. So does it require a printer? Does it require a monitor? What is required for your system to make it a success? Finally, in the analysis, and this is the most important part of the analysis in all honesty, you must have measurable success criteria. Success criteria is the things that you will do, and therefore you will know that your system is a success. What you must think about, and the reason it's measurable, is you have to be able to test for this. How will you know it's happened, in other words? So when we think about this, let's go back to Eugene. We've said that Eugene requires this yellow background. We will know that this system is successful whenever Eugene's login details are used. The system recognises that it's his login details and therefore changes the settings of the background of the screens to a yellow colour. Whereas when another user logs in, that doesn't happen. Maybe it stays white and black, as in with my slide I've got here. If it does those things, you know it's been a success. That's quantifiable. You can see and test whether that's happened or not. There's no vagueness about that. And this is what we're looking for. We're looking for this clarity in those processes. Has it happened or not? Moving on to the design. The design is all about deciding what the system's actually going to be like, how it's going to work. So our first step is therefore to do a module chart. A module chart is where we break down the entire system into small, separate chunks. You can see I've given you an example of one here. You can see I've got a stock system. It has different sections, and you can see that these different sections are related to each other. So the functions section has all the stuff about looking and using a product. The user thing's separate because that's how you sign in, how you sign up for the system. Whereas the product section is all about actually the database elements of the system. So adding a product, deleting a product, editing a product. And then finally, we have a payment section. So the management of that process, how does the user make a payment? Do they receive confirmation of that payment? What's going to go on through that process? Okay, our next section to look at is the system overview. So we've broken down our elements into a module chart, and then we want to think, well, how is the user actually going to navigate through these elements? So in other words, we can create a flow chart here, and you can see my example here. The user arrives at the website, they search for the product, and then they choose their product. They add that product to the basket, and then they go on to then pay and sort of receive confirmation that they've chosen that product as they go forwards. So by thinking about this logically, we can then think about what steps, what orders the process is going to take place. Mine's quite a simplified one. You obviously would need a much bigger one, a much more considered one across all of the system elements that you're going to have. We then need to think about our data structures. So in other words, the data that's actually going to be used within the system. And the more detail we can think about this, the better. So for example, validation will be massively impacted by the choice of data that we use. How are we going to ensure that the data is consistent, that it's accurate, and also that it aids any sort of security features of the system and then helps the system sort of maintain sort of working in a correct manner. So we'll think about the different aspects here, the different features that would become important to it. Again, we can think about validation, how that's going to impact on the actual choice of our user interface. So for example, you can see here I've got an input form, I've got input boxes to include where you would put in things like the full name, email, password, etc. I've also got some radio boxes and some drop-down menus. I've also got a date section as well. When we think about this, as validation required all throughout these things, text boxes in many ways are a very vulnerable part for a system. You could potentially put in malicious code in there if you wanted to. So therefore, we want to try and limit that down if we can. So therefore, we want to maybe set what the character limit is for that input box. And if it's, say, something like a password, what characters are going to be allowed, uppercase, lowercase, etc. When we think about drop-down menus and radio boxes, both of those are really easy to use tools, but they really limit down the choices a user can make. In other words, it adds a control to the user. What I would say is if you want a sort of information that's been chosen to potentially change over time, a drop-down menu is easier to manage than a radio box, because the radio box is going to change therefore the actual user interface design, whereas the drop-down menu can just be, that list can be added to. So you can see I've got 4 countries there. That is easy to add a 5th, a 6th, a 7th, etc. from that. We also need to think about things like date formats. Something like a date has a lot of potential pitfalls. When you think about it, we have a UK format, there's the US format, or you can even just write out a date using full sort of written words as well, can't you? So we need to decide that in advance. What is the method that we're going to use so we get consistency across the entire database? And this is going to obviously then impact on things like the user interface design, the way we structure our database, all of these sort of elements. So it's crucial we think about this. Also, by thinking about our data types, we can start to then get an idea of how much data is going to be required to store each user's data, be that the products they've bought, be that their information, whatever it might be. So, for example, if we're going to allow, say, a string to go into an input box, and we therefore are going to allow 50 characters to go in there, we therefore can sort of calculate that that's going to require 100 bytes of data to store that information. And obviously we can then start to make predictions about how much storage they're going to need, how that might impact on the RAM performance, all these other features that are going to come from that knowledge. What I would really recommend you do is to use a table for this. That by having the headings that you can see, you're not going to forget to mention things. So for each user interface, I would have a data type table. Each element should be mentioned, so an input box, a button, a radio box, whatever the choices that you've got. Then talk about the data type and the different storage elements to it, etc. But then also think about the validation. And then, probably most importantly of all, justify your decisions. You cannot get into the top grade boundaries unless you are justifying your decisions and why you have done things throughout the entire NEA. It's the most important thing you can do. Next, we can move on to other aspects. So we want to think about the actual user interface. Now we've thought about that data type and how that's going to impact on this. Now we want to think about it as itself. How are we going to aid the user using our user interface? What kind of things are we going to include? Are we going to include alerts, error messages, tooltips, advice, sort of some of these accessibility features that we've already mentioned with Eugene needing colour changes in the background? So you can see I've got a user interface design here, a very simple one for a login screen. And you can see that I've annotated it. And again, I've labelled and named each of those components. So you can see my button is BTN login. By having a standard format like that, where I've called it a name and you can tell it's a button versus when it's a text box, so TXT, it's meant that it's going to make the coding much easier because I'll know which thing I'm referring to. Again, by annotating it and showing where things are located, it's easy then, or much easier, to replicate that then on the computer when you come to code it and design the system moving forwards. I would really, again, encourage you to actually answer these questions within your design. So how will the user navigate through the system? How will that user interface be kept consistent across a number of pages? What alerts are you going to put in place? What automatic elements are you going to put in place for the user? Just think about these things, and again, the more you can explain about them and justify them, the better your design is going to end up being. When you're doing your user interface design, I would really encourage you to think about the layout. In sort of England, and therefore sort of Western culture, we read from left to right, don't we? So you can see from this slide, I've done exactly that. The title will have been the first thing you probably read. And you'll have also maybe noticed that there's the yellow box there where it says about the eye movement and that's good design. What you may not have even spotted yet, though, is in the bottom right-hand corner, there's a red box there where it says the features here will often be missed. There's two reasons why they'll be missed. One, I've got a red feature on the back of the slide, which therefore you've already got used to seeing and therefore won't necessarily spot that writing there, but also because it's not where our eye is naturally being drawn to. So in other words, in your user interface, you don't want to include essential items in that location of the form, buttons, etc. Move them elsewhere so they can be found. This is something you can therefore talk about and justify your layout, justify your design for your system. Other features you might talk about are how the system will be actually used. How are you going to cope with errors? How are you going to cope with mistakes that the user might make? How are you going to limit those potential options for mistakes as they go through? You can see, for example, from my flowchart here, that the user may choose a product, add it to the basket, but they may not actually be logged in at that stage. They therefore may not have a login at all and therefore need to continue as a guest. They may choose to then sign up at that point. They may choose to sign in at that moment. What we can't obviously have then is that if they're signing up and we fill in a new form, that their choice of product has then been lost. We must retain that data because that's going to obviously be a poor user experience for them if once they've signed up, they then discover that all of their choices for products have disappeared. So we want to think about these things and think, well, how can we cope with that sort of choice of process to happen that wouldn't necessarily have been our perfect choice? We probably would have preferred them to log in as soon as they arrived at the website. So how can we make sure it doesn't matter if they choose to do that later on in the process? Also, what we must really think about with our user is accessibility issues. So is there issues to do with vision? Are there issues to do with the type of tools that they're going to use? So will they need specialist equipment to actually use the system? Will it need to be able to be have a voice reader using the system and therefore tell them about the different options that they have? In any of these features, we need to think about this and then make sure we include these features within our final system. Moving on then, we need to think about the logic of the system. So you can sort of see we've got a pattern here. We've got a user interface, we've got the data types for that user interface, and then we want to think about the logic that's going to be applied on that particular user interface. So we want to think about the processes. We need our algorithms. When we're thinking about our algorithms, ideally we'll use pseudocode. We will have, as you can see there, I've got an example of it. It looks similar to normal code, but it isn't specific to any one language. So it isn't Python, it isn't C++ that's being used there. If you were to start to use Python or C++ in there, I'm sorry, but that would look bad. It would look like you've just copied and pasted it from your code and you did this afterwards. So make sure this is pseudocode and not actual code that you're using. As an alternative though, you may also use flowcharts. And again, I would encourage that. It's a nice visual way for it to look. But in doing so, make sure you justify your choices. Why have you designed the logic in this way? What's the reasoning for that? Moving on then, you must also test. And I can't lie to you, testing is possibly the most important part of the entire NEA. There's probably more marks associated to testing than there is to anything else. So in other words, we need to plan for this in the design. What tests are going to need to be carried out for each user interface as we go through? And you can see now we're forming a pattern. I have a user interface 1 that is then has data types for it, has the algorithms for it, and then has the tests that are going to be carried out on it. I then do user interface 2. I then do the data types for user interface 2, I do the algorithms for user interface 2, and I do the testing for user interface 2. And then I move on to user interface 3 and continue. And obviously you would repeat that process for however many user interfaces you have. Again, what I would encourage you to do with testing is to put the data inside a table. It's easy to do, and it also means you don't forget to include key information such as validation you're going to include, what you're expecting to happen from that test, and again, justifying that test. Why is that test being carried out? What does it tell you by carrying out that test? Next, we want to move on to our success criteria. Remember, in the analysis, we talked about success criteria, and I said about how important this was. You must take that success criteria from the analysis and now design actual tests for it. What tests will be carried out so you know that thing has actually happened, okay? And again, I would do this in a table. So going back to my original example, I said about Eugene and to require a yellow background. That's the criteria that must happen. Therefore, I can do a test for that. I use Eugene's login details, and when it goes to the main menu should appear with a yellow background. And then any user interfaces from then on will also have that same yellow background. If that happens, I know my test is successful, and therefore I can carry, when I come to do this in my development, I can then put a screenshot inside these, my table to show that that's worked. And again, as I've said before, justify it. Why is that test going to make sure you've met that criteria? What evidence is it going to provide to prove that? Okay, now we're moving on to into our third stage, the development. The development is worth more marks than any other stage and is where you will spend most of your time. This is where we're actually doing the coding. The way you need to approach your coding is by module by module. So in other words, if you go back to my modules, if you remember, I had a module that was to do with the user, where I had the sign up and I had the login and the management of that process. So in other words, I would potentially start with that. In other words, I design the user interface for that. I design the database that's going to store the user's information. And then I then create the sign up page and the login page. And I go through the process of writing the algorithms to make sure that that happens. Once I've done that, I can then carry out my testing of it. So in other words, I'll test that user interface and then I'll move through in doing so. So we then end up with a pattern. We have a module. We have our first go at it, in other words, our prototype, our first prototype. I then carry out iterative testing while I improve and change that prototype. I then move on to a prototype 2, in other words, a second version of that original user interface, in other words, an improved version. I then need to test that again. Once I think I'm happy with that section, that module, I should then do an end of review test where I check everything. Okay, and you can see here, I've mentioned it there, about testing for things like validation, testing for procedures, the logic, but that happens in a sort of a grand finish, if you like, for each module. That should be really clear and really easy to find for the examiner. We're playing a game at the end of the day. We want to make sure the examiner can find our evidence. So give it clear subheadings, give it titles that show that this is the review of your module. Okay, so I'm just going to move through a simple example of the types of things that are going to happen. So you can see that I've included a screenshot of my login system that's been designed. You can see I've given some explanation about it, a bit like a storyline, a diary of what's going on. I've then included a screenshot of my code, and you can see that the code is annotated, and it also again has a description of what's going on and why and how as we move through. That was my first prototype. What I should have done there, I didn't actually show it, but I should have tested it as well. Then we move on to prototype 2. So you can see now that I'm trying to improve it, and I'm basing these decisions for improving it on those tests that I would have just carried out. So as I go through, you can see I've got some more code. Again, I've screenshotted the code and I've included more elements. So now you can register as a user. And again, I've included the screenshot to show this is happening. The examiner never sees your working system and therefore needs as much screenshots and as much code and as much details as you can possibly give them so they can really understand and feel like they're using the system and understand what's going on with the system. And you can see I'm doing this, I'm including those different key elements. Again, I carry out some testing of that. So I'm testing the system. Does it do what it should do? Excuse me. Does it behave in the correct way? Does it manage those processes as we move through? Again, this is the table from the design. Literally take the table you did in the design, copy and paste it into your development, and then fill it in with those screenshots. And you can see I've done that. I've put screenshots showing the things have happened successfully. And also I've indicated very clearly where something has failed. What we want to then do is try and fix that problem. Try and carry out some form of solution. Ultimately, if you can't fix it, that is not the end of the world. What matters more is that you tried. And therefore you talk about that journey. What different changes did you make to your code to try and make it work? What efforts did you put in place? What decisions did you take as you went through? Again, we need to talk about the validation. So what validation did you include within your system? What kind of processes were there? How did you check that a password is in the valid format? What sort of things did you include as you were going through that? And again, we're showing an awareness. You can see in my comments here, I've tried to do some validation, but what I've also done is said that really I need to take that validation further. I need to include upper and lowercase elements. I need to include symbols and think about a minimum length of password as I move forward. Again, I might even bring in some hashing as well into that algorithm to really make sure it's secure. So now I'm going on to my prototype 3. So you can see I've gone through a journey now. I had a basic one, I created it, I tested it, and then moved on to a slightly improved version where it had a register system added to it. And then again, tested that and improved it. You can see that for my prototype 3, I'm very aware of what works and what doesn't work. And that's crucial to the success of your system. So again, I've now further enhanced my code. I've now started to bring in images to make the user interface look more desirable and attractive and easier to perhaps use. And again, I've explained what's going on and why I'm making these choices. I'm justifying my decisions. Okay, you can see my final prototype here. The look of it, the layout of it is much more sophisticated. You can see that it's got colour in there, images in there. It's a genuine improvement, isn't it, on my earlier version. So again, I've shown that. And again, I can justify why I've done it in this way, why I've made these decisions, why I feel that this is a better outcome than my original sort of first attempt. And again, I now test it. I'm testing for things like is there now validation in there? Does it let things happen? And you can see that I'm showing which tests are being passed and which tests are failing. And again, it's important that I show that, so I'm showing that I'm aware of what works and what doesn't work. Again, I've included screenshots of certain features. So for example, you can see with the password, I've put a mask onto it so you can't see what's been written in that input box. And again, it's just a feature that an examiner can't ever see for themselves because they don't use the system. Therefore, it's crucial I screenshot that and evidence it so that they know it's in there and that's happening. We then move on to our evaluation. Okay, our evaluation again is worth more marks than either of the analysis and design. So again, it's a crucial element, and it's something that I've found over the years that students often ignore because they're too worried about developing and therefore leave this to the last minute. And it's a mistake to do that because it's too important. It's got too many marks added to it and kind of being gained from it. So when we're doing this, it's crucial we test the function of your system. So you can see here, I've done that within this table. I'm testing the functionality. I'm checking that things work. So in other words, data is added to the database, that it calculates prices correctly. And therefore, I'm showing again what works correctly and what doesn't. And it's clear from the table that that's happening. We must also test for robustness. In other words, can you break your system? So test for valid data, test for invalid data, test extreme data as well. And again, you should therefore get sort of outcomes from that. So you can see with mine, it should give error messages when it's not sort of the correct type of data. And again, you can see clearly from a table that this works correctly. We also need to test for usability. So to test for usability, in other words, we're asking our user, do they like our system? Can they use our system? What sort of features in there do they like? Have they used? So an interview would be a very good idea here. Maybe a survey of users would be a very good idea. We want to get evidence and their feedback about the system. So once we've done that, we then need to actually show our post-development testing. So again, we designed this back in the design. If you remember, we took the success criteria and we created a table that was going to test for each one of those success criteria. All we need to do now is literally copy and paste that table into the evaluation, and then we need to actually carry out those tests. In other words, we're going to establish now whether the system has been a success or not. In all honesty with you, you don't want all of the criteria to have been a success. It's actually better, ironically, if one or two of those don't actually work correctly, because then it gives you things to talk about for the future and talk about how you'd like those to be fixed down the line. Because what we need to then do is talk about how we'll maintain the system in the future and what we'd like to happen to the system in the future. How would it be further developed? In other words, the things that didn't work properly or that weren't achieved in your success criteria can be the very things you talk about here. In other words, I'd really like it if a programmer came along, took on my system and then fixed these issues I was having and therefore improved it in the future. And I'd like to see the design develop in this way in the future from it. When we're thinking about maintenance, there's different types of maintenance we should talk about. We should talk about adaptive maintenance. So in other words, what happens with your system? Is your system self-contained and will work forever and will work regardless of the hardware it's on, what Windows operating system it's on? Is that just going to be a self-contained entity? Or is it something that's going to be used and needs to be constantly updated? Are users going to, like, say like in a college, new students join a college each year and then they leave a college each year. So that massive data shifting, who's going to manage that? Is that going to need, therefore, does the business need to make sure the employer member of staff to manage the system and manage the data on there? Again, are there any elements about sort of the system that kind of are going to be impacted by the law and changes to the law? So obviously the most recent one that kind of springs to mind would be the GDPR and the changes from that from the Data Protection Act. And again, the use of cookies. So for example, now, whenever you visit a website, you'll always get asked about whether you accept the cookies or not, don't you? So again, is that something that's going to need to be a feature of your system as you move forwards? Again, does your system have, say, a database that's going to get bigger and bigger and therefore is going to require new hardware being bought down the line to maintain and keep that system running? We also need corrective maintenance potentially. So as that system gets installed, how are bugs going to be fixed? How are bugs going to be kind of identified and therefore altered and corrected down the line. So you need to plan for this. What's going to happen? What would be your intention with it as you move forwards? And then again, finally, our perfective maintenance. So in other words, what is this system going to stay exactly like it is at the end of your project? Or would the idea be that it's going to get better and better and better into the future? And what would that feel like? Just talk about it. Explain what you'd like it to be like, what features you'd like it to include. How would you would expect the business to go around solving these problems. Okay, so I hope you found that really useful. I really hope you kind of feel like you have a really clear idea now about what you need to put inside the NEA. I just want to pick up on a few things. You must meet the criteria in each grade boundary. They mark it on a best fit basis. So in other words, if you have the grade criteria open and you can see that you've met all of that criteria, you're going to be pretty confident you're in that grade boundary. And again, it's all about confidence. So justify throughout. If you are meeting all of the criteria and you're justifying throughout, then your teacher will feel confident about giving you the higher grade that comes from that. And remember, we're playing a game really. We're trying to prove that we have created this thing and we need to show evidence as much as we possibly can. So don't assume anything. Make sure it's explained, even if it feels like you're explaining the absolute obvious. Don't worry about that, because that shows your thinking, it shows your decision making. The other final thing I would really say is don't stop when you hit a problem. I've seen too many students doing this over the years. They hit a problem where they don't know how to solve it and they just stop, they just grind to a halt. Don't do that. You just waste time as a result. You're much better to move on to something else within the system that you can do. So start creating the second user interface, start working on the third interface, start working on the algorithms that are going to work within that you can do. And then give yourself a bit of time to solve the problem. So rather than stopping and not progressing, come back to it later on once you've done those other elements, and then you've got a bit more time to focus on fixing that problem. Okay, well, best of luck, guys, with your NEA, and I really hope that you found this useful. Please do like and subscribe this video if you found this useful, and subscribe to my channel, and it'd be great to see you using the videos and hopefully getting the best from them. Okay, all the best, guys. Thanks a lot.